This next unit is all about working with quadratic equations. Quadratic equations are polynomial equations where x is squared, so the equation has two solutions, or we can call them roots. If we had x to a higher power than 2, then the equation would have even more roots. In this lesson, we are going to look at solving polynomial equations that include polynomials that are factored completely already. To do this, we're going to use a basic property of arithmetic, the zero product property. So what exactly is the zero product property? Remember that the word product means the result of a multiplication problem? So what we have here is a property that relates to a multiplication problem that equals 0. This means that if a times b equals 0, then either a equals 0, b equals 0, or both a and b equals 0. For example, if 5a equaled 0, we know 5 doesn't equal 0, so a has to equal 0. If 10b equaled 0, then b would have to equal 0. If we have another variable like x, it will still work. If 3x equals 0, then x equals 0. So what does this have to do with polynomial equations? Let's find out. If we have a polynomial equation where the polynomial is completely factored, then we can use the zero product property to find all the solutions to the equation. Let's consider the equation x minus 5 times 2x plus 7 equals 0. You'll notice that the two sets of parentheses are multiplied together and equal 0. So according to the zero product property, either x minus 5 equals 0 or 2x plus 7 equals 0. If we write two equations like we have here, we can solve each one separately to find the roots of the equation. For the first equation, we need to undo the minus 5 by adding 5 to both sides to get x equals 5. The second equation will take two steps to solve. First, we'll undo the plus 7 by subtracting 7 from both sides, so we have 2x equals negative 7. Then we'll divide both sides by 2 to get x equals negative 7 halves, which equals negative 3.5 or negative 3.5. Now that we've solved both equations, we know the roots of the equation are x equals 5 or negative 3.5. As with other equations, you can always substitute your answers back into the original equation to check your work. Here, if we plug in 5, we get 5 minus 5 times the quantity 2 times 5 plus 7. And the question is, does that equal 0? We have 0 times 17, which does equal 0, so we know 5 is correct. If we plug in negative 3.5, we get negative 3.5 minus 5 times 2 times negative 3.5 plus 7. And again, does that equal 0? We have negative 8.5 times 0, which does equal 0. So we know negative 3.5 is correct as well. Notice that it didn't matter what the other factor equaled in each case. As long as one of the factors equals 0, the product will be 0. Now let's look at an equation with three sets of parentheses. 2x minus 5 times 5x plus 9 times 4x minus 3 equals 0. Since there are three factors, any one of them could equal 0. 2x minus 5 equals 0, or 5x plus 9 equals 0, or 4x minus 3 equals 0. Now we solve each equation to find the three roots for this equation. First, add 5 to both sides of the first equation to get 2x equals 5. Then divide by 2 to get 5 over 2, which is 2.5, or 2.5 as a decimal. Next, subtract 9 from both sides of the second equation to get 5x equals negative 9. Then divide both sides by 5 to get negative 9/5, which equals negative 1 4/5, or negative 1.8. For our third equation, we need to add 3 to both sides to get 4x equals 3. Then we divide by 4, and 3 over 4 is 3/4, or 0.75 as a decimal. Now we know all 3 roots of the equation. X equals 2.5, or -1 4/5, or 3/4. As you get more and more comfortable solving equations with the zero product property, you can start to recognize a pattern to find the roots without having to write out all the equations. In our examples from before, the factor 2x minus 5 gave us the root 5/2. 5x plus 9 gave us -9/5. 4x minus 3 gave us 3/4. 2x plus 7 gave us -7/2, and x minus 5 gave us +5/1, or just 5. If we look closely, we can see the pattern. First, notice that the numerator of each root is the opposite of the constant term of the factor. Also, the denominator of each root is the same as the coefficient of x in each factor. Once we notice this, we can find the roots by saying that x equals the opposite of the constant over the coefficient. This is a nice rule that will work no matter what the factors are. For example, x times 2x plus 3 times 4x minus 7 times 5x plus 1 equals 0 is an equation that has 4 roots. The first factor, x, has no constant term with it, so we could look at it as though it's x minus 0. So x would equal 0 over 1, which is 0. The factor 2x plus 3 gives us the root minus 3 over 2. The factor 4x minus 7 gives us +7 over 4. And the factor 5x plus 1 gives us the root -1 over 5. Now we know all 4 roots. Now that you know how to find the roots using the zero product property, you're ready to take the next step and try solving quadratic equations by factoring.